So let's start building a geometric intuition into conjugate points. What we have on this page is a recap of what we've done before. We derived this equation here for the second variation. We said that if this value here is less than 0, we would have a maximum. If it's greater than 0, we would have a minimum. And we had to ensure that this here didn't equal 0. And the way we ensured that this didn't equal 0 is that we made sure that the function u of x didn't go to 0 anywhere within these limits a and b. And we called this point a, then it meant that this point a dash would be the conjugate point. So we're going to consider two examples on the next page that gives us a bit of a better geometric intuition into the nature of conjugate points. Let's look at the example of a sphere and also a parabola. Now I have a sphere drawn here and we have the great arc of the sphere here. So if you like, you can think about this as the planet Earth, and you can think about the great arc as the equator. Now the question that we're going to pose is, what's the shortest distance between the 2 points A and B on this great arc? Now it's plain and obvious from here that the shortest distance is going to be from here along this path to this point. But we have another option. The other option is to go from A all the way round and get to the point B. But obviously that's not going to be the shortest distance. So we can call the shortest distance here, if you like, an extremal. Now if we were to travel from here all the way round, we would actually break one of our rules that we set on the Jacobi test. If we were to travel from here all the way round, then in fact we would be travelling from A to a point B, but we would be travelling through this conjugate point A dash, because this point here is at the opposite side of this great arc, and this is a conjugate point to this point here. So that would mean if we travelled round this way here, then in effect we would be travelling along here and we would hit the A dash, and the A dash would be in between the A and the B. So that would mean that this value u of x would actually go to 0 within this area, this length here, AB. And that would mean that the second variation would go to 0, and we would have to look at the fourth variation in order to try and find out the extremum type. So we don't want that to happen. So this really tells us that if we were going to go the shortest distance around the great arc, we have to ensure that we don't pass through any of the other conjugate points. That is, we have to make sure that this conjugate point, A dash, is outside AB. And that's what happens when we travel from here. So when we go from here to here, we don't pass through that conjugate point. So this is the extremal, which is the shortest distance, whereas the other path is not going to be an extremal. So that's the first example. Now the second example is projectile motion. So we can think about this as, if you like, an old-fashioned cannon. So if we set the cannon at this point here, and we were to fire, we take a certain amount of gunpowder and a certain weight of cannon and the ball, and we were to fire that straight up, then it's going to go straight up, it'll hit this point and come straight back down. So if we call this point A, then this point up here would be A dash, that is, it would be a conjugate point. Now if we were to take the cannon and angle it slightly, then the cannonball is going to go up and come back down. Now this point here is going to be A dash, so this is another conjugate point of A. Now we could continue doing this and we can continue adjusting the angle of the cannon. So here the cannon is sitting at a low angle and it would fire out and it'll land at this point here. So all of these points, A dash here, and also if you turn the cannon round the other way, it would be symmetric and these would be our A dashes. So it would mean that we would create an envelope here of conjugate points. And that envelope here would give us the maximum distance that the cannon could fire. So if you like, if we had an aeroplane flying past here, then it won't be within the cannon's range if it lies within this envelope. So that shows us that we don't just need to have one conjugate point, we can have an infinite number of conjugate points. Now we'll go and have a quick look at this in the graphical calculator, but we will come back to this example later on and we'll look at it in more mathematical detail. If you head into the resources section, you'll see that you have a file there for the graphical calculator. So if you like, you can open that up and have a look at it. But we won't go through it in any detail in this video. In a future video, we'll go through the parabola in more mathematical detail. But it gives us a bit of an understanding here of the conjugate points. So you can see here that the cannon's going to be sitting at this point here. The furthest it's going to fire is over to this point over at the edge, and obviously at this point here as well. And these are some of the envelopes that we've got drawn up for the cannon. And you can see if we fire it straight up, it's going to hit this point here. But if we fire it over here, it's going to hit a point along here. Now, we can actually, if we were to add in an infinite number of these, we would create this envelope here. And the envelope would be an envelope of conjugate points. And here's a conjugate point here. So what we'll do is we'll shift this along and you'll see it actually going over and jumping between each of these. So if we move it to the next one along, you see it jumps from one to another and it's jumping all the way along, and it's actually generating it would generate the entire envelope. And you can see that I've got it written down in terms of a focus, and also we'll have a directrix, and we'll see that whenever we go on and look at it in a bit more detail. But this gives us a good indication of the geometric beauty of our conjugate points. So that's all there is for this video. We will go back to the sphere and the parabola and we will look at them in more detail in future videos. So thank you for listening. I'll get you on the next video. Goodbye.